welcome to the new section, and in this section I'm going to talk about the chapter 2 queuing problems, so single channel queuing problems, how we can able to solve by using the different parameters, like the different kinds of problems that we solved in chapter 2. So I'm going to repeat the same things so you can just see and understand. And what is the basic things is like complete the simulation table for a single channel queue. So this is the manual simulation. By computing the time service begins, so I have to calculate the time service begins, time customer waits in the queue, and when the time service ends. Time service begins is nothing but the arrival times, the arrival time, and when the customer is going to take the service from the server. And the time service ends is nothing but uh, when they are going to departure, and how much is the time customer spends in the system with server, and the idle time of the server. What is the idle time of the server? And we're gonna see how to calculate these values: average waiting time, probability, and different kinds of things. First, the inter-arrival time is given, and the number of customers or 6 customers. So total number of customers here, just to make it, because I want to make it bigger. Okay, no problem. I will just hold. So total number of customers are 6, and so I have to calculate the arrival time. The first arrival time is 0, and the second arrival time is nothing but you have to add this next values. So 0 plus 3 3, and the third one is 3 plus 1 4, and the fourth one is 8, and next one is 10, next one is 15. So this is easy, and the total arrival time is 15 minutes. So total we have to calculate, and the time service begins is service time I given in the values is 2 to 5, and the time service begins, how you're going to calculate is, I will just say E is nothing but greater of or maximum, you can say max of time service ends of previous row, previous value, comma, time service begins of current value. And the time customer waits in the queue is nothing but F equal to time service begins E minus arrival time, E minus C, and the time service ends is nothing but service time plus time service begins, Z equal to service time plus time service begin, D plus E, and time customer spends in the system is time service ends minus arrival time, H equal to Z minus C, and the idle time of the server is nothing but difference of time service begins TSB of next value minus TSC of time service ends of previous value. Time service begins of the current value. Okay. So the time service begins for the first customer will be 0, because he is just coming, the inter-arrival time is 0, and the time customer waits in the queue is nothing but time service begins minus error, it's a 0. Time service ends is nothing but 2 plus 0, 2. Time customer spends in the system is nothing but time service ends minus arrival time, it's 2, and the idle time of the server is coming for the first customer, it will be 0. And time service begins, you have to compare time service previous value of time service ends and the current value of arrival time. And what is the maximum value in between these two? Time service ends is 2 and time arrival time of the one is 3. So 3 is greater. So put 3. And time customer waits in the queue is nothing but time service begins when the service is going to begin, and what is the arrival time. So 3 minus 3, 0. And time service ends is nothing but service time plus time service begins, and the time customer spends in the system. So how much time the customer is going to spend is nothing but ends departure minus arrival time. So departure is departing after 5 minutes and is coming at 3 minutes after the first customer. Second customer is so 2. Idle time of the server, when the server is being idle, it's when the service begins minus service ends. So service begins of the current value, and this one is time service begins is of the current value. It should be current. Time service begins of current value and time service ends of previous value. Yeah. So time service begins of the current value is 3 and time service ends of the previous value is 2. 3 minus 2, it's 1. Next one, time service begins, so compare 5 and the arrival time 4. So he is after this departure, the next customer is going to come at 5 minutes, and time customer waits in the queue is nothing but 5 minus 4, 1 arrival time, and time service ends is nothing but service time plus time service begins, so it's 10. And time customer spends in the system 10 minus arrival time, it's 4. 10 minus 4, 6. And idle time of the server is 5 minus 5 is 0. It should be here. Yeah. And for the next one, fourth customer, time service begins is time service ends 10 and the arrival time is 8. The maximum value of these two is greater value is 10. And time customer waits in the queue is nothing but time service begins minus arrival time, it's 2. And time service ends is nothing but service time plus time service begins, 16. And time service spends in the system, customer spends in the system is nothing but ends minus arrival time, 8 minutes. And idle time of the server is the current value minus time service ends, 0. So here time service begins, it's ending at 16 minutes, and the next fifth customer is coming at 10 minutes. Maximum value is 16. And time customer waits in the queue is 16 minus 10, 6. And time service ends 16 plus 3, 19. Time customer spends in the system is nothing but departure minus arrival, 19 minus 10, 9. And the idle time of the server is 16 minus time service ends of the previous value, 0. The one time service begins 19 and 15, the maximum value is 19. And time customer waits in the queue is nothing but when the customer, how much time the customer spends in the queue, it's 19 minus 15 is 4. And time service ends is nothing but service time plus time service begins, 21. Time customer spends in the system is nothing but time service ends minus arrival time, 21 minus 15, 6. Idle time of the server, so kindly double check these values, I'm just doing it. Idle time of the server, just try to understand the basic concept. It's like 19 minus 19 is 0. Yeah. So total customers are 6 and the arrival time is 15, and total arrival time is 15, and time service begins. Time customer waits in the queue. How many customers are there? Total number of customers who wait. So I will just add total number of customers who wait is remove zeros and whatever the integer values that you're getting. Out of 6 customers, these 4 customers are waiting, who wait in the queue is 4. and total time customer waits. Total time customer waits in the queue is customers wait in the queue is equal to how much? It's 2 3 9 plus 4 13, so total is 13. And time service ends, and total idle time of the server is 1. Yeah. Now I want to say average waiting time of a customer is nothing but total time customer waits in the queue. Total time customer waits in the queue divided by total number of customers. So these are the formulas that is already there in the chapter 2. Just follow, and you can see total time customer waits in the queue is 13 divided by total number of customers are 6. Yeah. And probability that a customer has to wait is total number of customers who wait. Total number of customers who wait by total number of customers. So total number of customers who wait in the queue is 4 divided by total number of customers is 6. So what is the fraction of idle time of the server? So idle time of the server is probability of idle time of total idle time by total idle time of server by divided by total runtime of simulation. So total idle time of the server is how much? It's 1 divided by total runtime. Runtime is nothing but how much is a run when the time service ends. So total runtime is 21 minutes. So it's 21 minutes the simulation is running. So 1 divided by 21. And what is the average service time? Is nothing but total service time by divided by total number of customers. So total service time is 5, 4, 9, 15, 20. So 20 divided by number of customers was 6. What is the average time between arrivals? It's nothing but sum of all times between arrivals. Sum of all times between arrivals by number of arrivals minus 1. Here, see, sum of all times between arrivals is you have to just find out the arrival time when they are ending. It's 15. So you can see the arrival time and it's stopping at 15. So what is the sum of all times? Is nothing but 15 divided by number of arrivals is how many arrivals are there? 2, 3, 4, 5, 6. Number of arrivals is 6. 6 minus 1. So 15 by 6 minus 1. So 15 divided by 5, so it's 3. Yeah. And average waiting time of those who wait is nothing but total time customer waits in the queue. Total time customer wait in the queue by total number of customers. By total number of customers who wait. This is same as, see, average waiting time of customers, but this is total number of customers. But here I want to find average waiting time of those customers who wait. So the total time customer waits in the queue is So it's 13, and total number of customers who wait is, see, you have to find the number of customers who wait in the queue is 4. Only 4 people are waiting, because you have to calculate only the integer values. So there are only 4 customers, 2 customers are not waiting, they are leaving. So it's 13 divided by 4. Yeah, and average time of the customer who spends in the system is nothing but total time customer spends in the system divided by total number of customers. So total time customer spends in the system is nothing but 4. So here in this column you have to just add all the values, 10, 18, 7, 33, 15, 20, 29, 20. So 33 is the one. So total time customer spends in the system is 33. Total number of customers is 6. So 5.5. Yeah. So these are the values that you have to find from this following table, like from the following values. Like you know how to calculate the time service begins, time customer waits in the queue, time service ends, total time customer spends and idle time of the server. So these are basic thing how to calculate. These are the formulas that is already there in the textbook. You can just find out these formulas, and we'll try to solve another problem. It will be quite similar, and here the table is completely given. It might be asked like what is the average waiting time, the probability that the customer has to wait in the queue. So we'll try to see how to calculate these things. So here you can see average waiting time of a customer is nothing but total time customer waits in the queue by total number of divided by total number of just increase the font size, it will be better. Total number of customers. So total time customer waits in the queue is here you can see is 56 divided by total number of customers is 20, and probability that a customer has to wait in the queue is nothing but number of customers who wait, number of customers who wait in the queue by total number of customers. So number of customers who wait in the queue, just see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So number of customers who wait, and these are the customers who doesn't wait is 7. I will just put, it will be easy, number of customers who wait in the queue is 13, and number of customers who doesn't wait is nothing but total number of customers who does not wait in the queue is nothing but, so total number of customers minus total number of customers minus number of customers who wait in the queue. So total number of customers is 20 minus 13. and so total number of customers is 20 as well. And number of customers who wait in the queue is 13 divided by total number of customers, and probability that a customer does not wait. How to calculate? This is nothing but 1 minus probability of customer who wait in the queue. 1 minus probability of, because we know the formula, probability of 1 minus probability of customer who wait in the queue. So this is nothing but a complement. Who does not wait is nothing but negation. So you have to use the probability always calculate in the distribution of 0 to 1. So 1 minus probability of a customer who wait in the queue. So I can say 1 minus, what is the formula? Probability of customer who wait in the queue is number of customers who wait by, okay, already I calculated wait in the queue. So nothing but probability of customers who wait in the queue is 0.65. 1 minus 0.65. So 0.35. So this is a 0.35. And probability of an ideal server is nothing but total idle time of the server, total idle time of the server divided by total runtime of simulation, total runtime of simulation. So what is the total idle time from this table? Is nothing but 18 divided by total runtime is nothing but, so total runtime that you get is time service ends. So when the time service ends is nothing but 86. So this is the total runtime. So it should 0.209. And probability of server is idle server is probability of server being busy. So nothing but same thing, probability of a customer doesn't, so negation 1 minus probability of server being busy. So I have to just say that 1 minus probability of server being busy is 1 minus okay, probability of idle server, 1 minus probability of idle time of the server. So 1 minus 0.2093, so 0.79. So average service time is nothing but total service time by total number of customers. So total service time is nothing but, so 68 divided by total number of customers is 20. And average time between arrivals is nothing but sum of all times between arrivals by number of arrivals minus 1. Sum of all times between arrivals by divided by number of arrivals minus 1. So sum of all times between arrivals is, like you can just see, so you have to just, so total arrivals is 82 divided by total number of arrivals is nothing but 20 arrivals are there, so 20 minus 1, 19, so it's 4.3 minutes. And so these are the times. You can see average time customer spends in the system also we can just calculate. I'll Let's do it. Average time customer spends in the system. Nothing but total time customer spends in the system divided by total number of customers. So total time customer spends in the system is 124. You can see this column by total number of customers is 6. That's it. I think so. It's pretty much. I think you can see time. So I am given the 4 columns. Customer. This is the next one. Fill in the following values. Customer time since last arrival. This is inter-arrival time when the arrivals, and service time. How much time the customer is spending with the server, and time service begins when he is going to take the service, and when how much time he has to wait, and time service. So time customer waits in the queue is nothing but TSB, time service begins, minus arrival time 0. Time service ends is nothing but service time plus time service begins 4, and times customer waits in the queue is nothing but begins minus arrival time service begins is 2, and time service ends is nothing but service time plus time service begins, it's 7, and this one time customer waits in the queue is nothing but begins minus arrival time, ends service time plus time service begins 11. So time is 12 minus 12 0, and 12 plus 4 16. So 16 minus 16 0, 16 plus 1 17, 17 minus 17 0, and 17 plus 3 20. And this is pretty much like we have seen probability of service, average service time. This is pretty much basic formula. Now we're gonna see about the newspaper problem. So I have given find the inventory simulation for the purchase of 100 newspapers from the compute the daily profit for 4 days. So let us see by cases how to calculate this one. First one is what is a daily profit, or how to calculate the daily. I need to calculate the daily profit. It's nothing but revenue from sales minus total cost of how many newspapers? 100 newspapers every day. 100 newspapers minus lost profit plus salvage from scale of scrap. First we will find out the cost profit of total cost of 100 newspapers. So in the question it's saying find the inventory, and we have to compute the daily profit for 4 days. 100 newspapers. So it's nothing but I given 100 newspapers total cost daily. So it should be unit cost. This is a cost price 0.50, and this is a selling price. Selling price is at what price he is selling, and what is the cost price he bought, like at what cost he has bought the newspaper per newspaper. So it's 50. Now the revenue from sales is calculated. So you have to just check every day he can sell 100 newspapers, but the demand for today is like only 80 newspapers. So how much revenue is going to get from the sale of 80 newspapers? So because the demand is today, every day the demand should be 100 newspapers, but today the demand is less. So if it is less than, the 80 is less than 100. Just see this condition. Is selling less newspapers than the required, so it should be 80 into just put it here. Yeah, 80 into, and how much is a sales selling price is 0.75, 60, and there's a loss profit. Because there is no loss profit, because he is selling only 80 newspapers, it will be 0. And the salvage from scale of scrap is like you have to because he's selling less than the 20 newspapers. Actually he has to sell like 100 newspapers, but he's selling only 80 newspapers, so he has to sell 20 newspapers to the scale of scrap. So it should be 100 minus 80 into what is the value, unit lost, what is a refund, salvage value is 0.15. So it's 20 into 0.530. The daily profit is revenue from sales 60 minus total cost of 100 newspapers is 50 minus loss 0 plus 3 is 30. And see, the demand is now 100 equal to 100. So the demand is 100 and he's selling 100 newspapers. There is no issues. So you can sell like 100 into sales. Selling price is 0.75. So 75. And there will be no loss profit, and there is no salvage from sale as well, because the demand and the whatever he's selling, the demand is selling, purchase is 100 newspapers. He's purchasing 100 and he's selling 100. So the demand daily profit will be, to use the formula, revenue from sales 75 minus total cost of 100 is 50, so it should be 25. Now demand is 120, but is only purchased 100 newspapers. So now 120 greater than 100. So, but see, he has purchased only 100 newspapers, but the demand for today is 120. Daily demand is 120. So he can only sell 100 newspapers. He cannot sell 120, but the demand might be more. So I'll be just putting 100 into selling price. And what is the loss profit from excess demand? Because of this excess demand is there 20, he has the demand for today is 20 more, and he will be losing some profit. So it should be 120 minus 100, so it's 20 into, and what is the loss profit here? 0.25. And what is the salvage from sale? 0. And the daily profit, you have to just use the formula. So revenue from sales is nothing but 75 minus total cost minus 5 plus 0 is 20. And here the same thing, demand is less, so it will be 70 into 0.75. So these are the use cases. One is less than, one is equal to, one is greater than, and one is 70. So it's less than 70 is less than 100, and the demand is 70, but he has purchased 100 newspapers. So he'll be he has to sell it scrap. So because he has purchased more newspapers than the he is selling only 70, because the demand is less. So 52, and there will be no loss profit. It's a 0 because it's he bought only 70. And salvage, because he has purchased 100 newspapers, he can only do, today's demand is only 70, so 30 newspapers he has to sell it as a scrap, because he has to refund those 30 newspapers for the scale of scrap. So 30 into 0.15, and the daily profit is, it's 52.5. It's revenue from sales minus total cost minus loss profit plus salvage 7. So this is how you need to calculate the daily profit. I may be asking like what is the maximum profit of all this one? So maximum profit for these 4 days, maximum profit from demand of, maximum profit from sale of newspapers from demand of 4 days is, you have to just check this column. What's the maximum value is 25, and what is the minimum profit? 7. Average profit, you have to just add all the values divided by total number of days is 4. So you can just add average profit is 13 plus 5 plus 20 plus 7. 65 divided by 4. I don't know how much. It should be something around so 65 divided by 4. So that is what we have to use the same thing for the other one. So this is what the newspaper problem is. I hope this will clear all your queries regarding the chapter 2, how to solve the single channel queuing problem and the newspaper problem. And if you do have any kind of questions or concerns, please do comment in the below video. And thank you for watching the video. Have a nice day. Take care.